National Electrical Code, specifically Section 110.14. B addresses the connection of aluminum conductors. According to this section, aluminum conductors, aluminum-clad conductors, or such conductors with fittings and connection devices are permitted to be connected to terminals of devices and to other conductors with solderless connectors identified for the purpose and listed by an approved agency. This means that to legally and safely connect aluminum wiring, you must use connectors that are specifically designed and approved for use with aluminum. The specific type of connector used plays a critical role in ensuring a safe and compliant electrical installation. In the scenario described, Buchanan Bcap B2-1 wire nuts were used to pigtail aluminum wires with copper wires. The key to determining code compliance lies in the listing and suitability of these wire nuts. Buchanan Bcap B2-1 wire nuts are indeed listed by an approved agency, specifically Underwriters Laboratories or UL, for use with aluminum conductors. This listing is essential because it signifies that the connector has been tested and meets specific safety and performance standards for use with aluminum wiring. The UL listing ensures that the connector is suitable for the intended application and that it can provide a reliable and safe connection between aluminum and copper conductors. Furthermore, the wire nuts must be appropriately rated for the size and type of wire being used. This means that the wire nuts must be designed to accommodate the specific gauge or diameter of the aluminum and copper wires being connected. Using a wire nut that is too small or too large for the wires can result in a loose or improper connection, which can lead to overheating, arcing, and potentially electrical fires. Therefore, it is crucial to select wire nuts that are specifically rated for the wire sizes being used. The process of pigtailing involves connecting a short length of copper wire to the aluminum wire using the approved wire nut. The copper pigtail then serves as the point of connection to the electrical device, such as a switch, outlet, or circuit breaker. This method is often used because many electrical devices are not directly rated for use with aluminum wiring. By using a copper pigtail, the connection to the device is made with a compatible material, reducing the risk of corrosion or failure. To ensure a proper and safe connection when pigtailing aluminum wires, several steps must be followed. Firstly, the aluminum wires should be carefully cleaned to remove any oxidation or corrosion. Aluminum is prone to oxidation when exposed to air, and this oxidation layer can interfere with the electrical connection. A wire brush or a specialized cleaning compound designed for aluminum wiring can be used to remove the oxidation. Secondly, an antioxidant compound should be applied to the aluminum wires before connecting them with the wire nut. Antioxidant compounds help to prevent further oxidation and corrosion, ensuring a long-lasting and reliable connection. These compounds typically contain zinc particles that create a conductive pathway and protect the aluminum from moisture and air. Thirdly, the wire nut should be securely tightened to provide a firm and reliable connection. The wire nut should be twisted until it is snug, but not so tight that it damages the wires. It is important to follow the manufacturer's instructions for the proper torque or tightness of the wire nut. Fourthly, the connection should be inspected to ensure that all wires are securely held within the wire nut and that there are no loose strands or exposed conductors. A visual inspection can help to identify any potential problems with the connection. The NEC provides specific guidelines and requirements for working with aluminum wiring. These requirements are intended to address the unique challenges associated with aluminum conductors, such as their susceptibility to oxidation and their different expansion and contraction rates compared to copper. It is essential for electrical contractors and homeowners to be aware of these requirements and to follow them carefully to ensure safe and compliant electrical installations. Aluminum wiring was commonly used in residential construction from the mid-1960s to the mid-1970s due to the rising cost of copper. However, problems with aluminum wiring soon became apparent, including overheating, loose connections, and electrical fires. These problems were often attributed to improper installation techniques and the use of connectors that were not specifically designed for aluminum wiring. As a result, many jurisdictions now require that aluminum wiring be retrofitted with copper pigtails or replaced entirely with copper wiring. When working with existing aluminum wiring, it is important to exercise caution and to follow best practices for safe and reliable connections. This includes using approved connectors, applying antioxidant compounds, and carefully inspecting the connections for any signs of corrosion or damage. Regular inspections of aluminum wiring connections are also recommended to ensure that they remain tight and secure over time. In addition to pigtailing, there are other methods for connecting aluminum wiring to electrical devices. One alternative is to use devices that are specifically rated for use with aluminum wiring. These devices typically have terminals made of aluminum or a compatible alloy that is designed to prevent corrosion and ensure a reliable connection. Another option is to use a terminal block or connector that is designed to accommodate both aluminum and copper conductors. These connectors typically use a screw or clamp mechanism to provide a secure and reliable connection between the different types of wires. Regardless of the method used, it is essential to follow the manufacturer's instructions and to use only approved components that are specifically designed for use with aluminum wiring. The NEC also addresses the ampacity of aluminum conductors. Ampacity refers to the current carrying capacity of a conductor, and it is an important factor in determining the size of wire needed for a particular application. Aluminum conductors have a lower ampacity than copper conductors of the same size, so it is necessary to use a larger size aluminum wire to carry the same amount of current as a copper wire. The NEC provides tables that list the ampacity of different sizes and types of conductors, including aluminum conductors. These tables should be consulted to ensure that the correct size of wire is used for the intended application. In addition to ampacity, the NEC also addresses the voltage drop in electrical circuits. Voltage drop refers to the decrease in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause lights to dim, motors to run slowly, and other electrical equipment to malfunction. Aluminum conductors have a higher resistance than copper conductors, so they are more susceptible to voltage drop. The NEC provides guidelines for calculating voltage drop and recommends measures to minimize it, such as using larger size conductors or shortening the length of the circuit. When working with aluminum wiring, it is also important to be aware of the potential for galvanic corrosion. Galvanic corrosion occurs when two different metals are in contact in the presence of an electrolyte, such as moisture. The more reactive metal corrodes, while the less reactive metal is protected. Aluminum is more reactive than copper, so it can corrode when in contact with copper in a moist environment. To prevent galvanic corrosion, it is important to use connectors and fittings that are specifically designed to prevent contact between the two metals. These connectors typically have a barrier or coating that isolates the aluminum from the copper. In summary, connecting aluminum wiring requires careful attention to detail and adherence to the NEC. Using approved connectors, applying antioxidant compounds, and following proper installation techniques are essential for ensuring safe and reliable electrical connections. It is also important to be aware of the potential for galvanic corrosion and to take steps to prevent it. Regular inspections of aluminum wiring connections are recommended to ensure that they remain tight and secure over time. By following these guidelines, it is possible to safely and effectively use aluminum wiring in electrical installations. Remember to always consult with a qualified electrician if you have any questions or concerns about working with aluminum wiring. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical shock and fire. The information provided here is intended for educational purposes only and should not be considered a substitute for professional advice. Always follow the manufacturer's instructions and the NEC when working with electrical wiring.